we're going to look at the last type of compound that we're going to have to name or write the formula for. So far we've looked at ionic and covalent compounds. We looked at some ionic compounds that were multivalent, and we learned that we can either write stock nomenclature or the old system. Now what we're going to look at is acids, and acids are really easy to identify because remember on your test what you're going to have to do is you're going to have to look at a whole bunch of these and think about which naming system to use, so you have to be able to identify it. The first thing we notice about it is it always starts with hydrogen. Now there is one exception to this. There's one thing out there that starts with a hydrogen ion and is not an acid. Any guesses? Water. And the reason being, hydrogen ions show us acids. There's our hydroxide ion, that's the other part of water. And that, what do you think that shows? It's not an acid, but it's a base. So it's going to be a neutral compound. There's our one exception that we're going to see. So with hydrogen ions, since those are always going to be the cation in your compound, all we really have to do is think about the anion. And we're going to have a whole list of rules that we're going to follow. Actually, it's not so much a list as a little chart that you see here. I don't use the chart so much, feel free, there it is, but there is plenty of space for you guys to also go ahead and fill in a flow chart, and this is the way I like to think about naming acids. The first thing that you're going to notice is that it always starts with hydrogen, so we will write that right up top. There's an H, and it could be one of two types. It could either be a binary acid, or it could be a ternary acid. And what's binary? What does that mean? Two. So you've got two elements for a binary acid. Obviously, one of those elements has to be hydrogen. So it's going to be hydrogen plus one other element. And the way we name those is we just name them hydroblankic acid, where this blank is filled in based upon this element that is put right there. So for example, if you had HCl, what would you call that? Hydrochloric. And acid. Yeah, and if you see it in the word form, it'll be easy to recognize because you're going to see the word acid, so that tells you right away to start with H. Okay, let's work this one though in the opposite direction. Let's say you see something like hydrosulfuric acid. Well, the first thing you think is it's an acid, so we know it's going to start with hydrogen. There is no place here in the word where you have the word hydrogen, so just over to the left-hand side somewhere, write a +1, because, and this is as good a place as any right here, let's make ourselves a note, that these guys are ionic. So you have to think about the charges. You have to think about making it a neutral compound. Okay, so we've got our +1 for hydrogen, and then sulfuric comes from what? Sulfur, which is just S. What's the charge? -2. So because of that, the way to write it is H2S. Okay, that's all there is for binary, except the other thing we want to mention here. How do all binary compounds end? What's that last little bit that you have? No, all binary compounds. Ide. So let's go ahead and write that up here. They all end in ide. When we come over here to ternary, what we end up seeing here is that it's not just going to be two elements, it's going to be at least three elements. So, in other words, it's going to be hydrogen combined with what? What is it combining with? Polyatomic ion. Good. So the way that we're going to name these is either blankic acid or blankus acid. And the way you figure these out, if you looked at your polyatomic ion sheets, how do most of those end? Two different possibilities. Eights and ites. So let's write that up here. 8 and ite. So in your little list that you've got right here, It tells you this information, what I'm going to do, but I'm going to go ahead and write it in a goofy little sentence. A way that you can remember what goes with what is that if you remember, I ate a humongous bite, which means if your polyatomic ion ends in ate, then that ending changes to ick. If your polyatomic ion ends in ite, then your ending changes to us. So you can remember it that way. You can just memorize it somehow. You can think about your oxygen. So you've got one more oxygen than in your polyatomics that end in ate, then you do ite. And just like with what we learned yesterday, ick is the higher. It was for the higher charge. So however you guys want to remember it, just you've got to know that eight's turn to ick and ite's turn to us. So if you had an example like this, H3PO4. First of all, keep in mind you're going to have to identify this from a list of all sorts of different compounds. You would first identify it as an acid because you see hydrogen there. Then you would say, ooh, it's going to be a ternary acid because you've got more than just two elements. Where's PO4 come from? What is that? Phosphate. So what do you think this is going to change to? It's kind of tricky, but what do you think? Yeah, and if you said phosphic right now, that's okay, but try and correct it, and I heard the right answer is phosphoric. There's no great reason as to why that is. There's no rule that says you have that or sound in there, but this is phosphoric acid. If it was H3PO3 coming from phosphite, that would be phosphorus acid in that case. Okay, opposite direction. Opposite direction. If we had something like, and this is the other one that's kind of a little goofy, it's not going to be let's see which one I want to do. I'll do sulfurous acid, but notice it's not sulfus acid, it's sulfurous acid. So sulfurous acid, we know it's going to be hydrogen because it's an acid. It's got a +1 charge. What does sulfurous come from? SO3, which is sulfite. Sulfite. So you look at that and know it's going to come from sulfite, which is SO3, and it has that -2 charge. So it becomes H2SO3. Okay? Now the only other thing that I want to add to this is we said that yes, these guys end in "ide," these guys end in "ate" or "ite," but if you looked on your polyatomic ion sheet, can you find other things besides things that end in "ate" or "ite"? And the answer is yes, right? Don't worry about the one like hydroxide. We know that's just water. There's a couple things we don't have to worry about. What's one that really catches your eye that would be different maybe? Anything out there? Okay, azide, another one? Okay, another one? That one I don't think even forms an acid. Other ides that you see on there. Cyanide. Okay, let's look at cyanide. In fact, I'm just going to even write exception. But really the exception being it ends in "ide, so I'm going to follow these rules. So if you saw something like this, HCN, you'd say, wow, it's an acid because it starts with hydrogen. It's probably going to be ternary because you've got a polyatomic ion in there. But when you look at your sheet, you see it's cyanide. So that's when you ditch the idea that it's ternary and you come back over here and you look at the fact that it ends in "ide, so you follow these rules. So now what do you think it'll be? That's it. Hydrocyanic acid. And that is all there is to it, except we have some examples now. So, first one, H2CO3. We know it's an acid because we see it starts with hydrogen. It's not binary, so I'm not going to throw in the term hydro with that. Instead, CO3 is what? Carbonate, so it's going to change to carbonic acid. Okay, good. HBr. How do you start that one? hydro, because you see that you just have bromide there. It's just two elements. It's binary. So it's going to be hydrobromic. Okay, H3PO3. Phosphorus, because that's phosphite. Phosphite changes to us, so phosphorus acid. Notice if you think that that is just like you spell phosphorus, which is on the periodic table, the thing that's different is phosphorus doesn't have that O in there. So just to kind of help you out. Okay, HCN, we just did this one. We saw that this comes from cyanide, so we have to use those ide rules, making it hydrocyanic acid. And then BrO2, what's our polyatomic there? Bromite. So this is going to be bromous acid. Okay, other direction. Here we have periotic acid. Well, it's an acid. I know the first thing I'm going to do is write down hydrogen. Doesn't really give me a place over here to write it, but I'm just going to throw it to the left-hand side here. It's going to be a +1. What? I don't see a hydro prefix, so it's got to come from my polyatomic ions. Which polyatomic ion does it come from? Periodate, right? Periodate, which you look up and you see it's IO4, and it has that -1 charge. Everybody find it? Periodate, IO4 with a -1. Which, this is maybe as good a time as any to mention this. I'm just going to make a little aside over here. Really, it could be any halogen. I'll do this with chlorines. You can have perchlorate, I'm sorry, I just messed that up. Perchlorate, chlorate, chlorite, or hypochlorite. All of these have a -1 charge if you just happen to see those on your polyatomic ion sheet. Now, what I want to mention about this is the name is hypochlorite. This hypo is just very coincidentally sounds similar to hydro, but it has absolutely no relationship whatsoever. So don't think that this means hydro. You'll see something similar to that on your homework, and I just wanted to point that out. Okay, hydroselenic acid. This is a hydro prefix. This is not hydro. So hydro means you have hydrogen +1. What else do we have? -2 for our selenide, H2SE. Arsenic acid, H, with +1. What's the polyatomic ion it comes from? Say it again. Arsenite. Arsenite. So even if you don't have a polyatomic ion sheet, you should be able to look at that and know that that's going to come from ite. So you would then look that up and see it's ASO3, and it has a -3 charge. Okay, chromic acid. Here we have hydrogen with +1, and then chrome, what's it going to come from? Chromate, CrO4 with a -2, so H2CrO4. And finally, big long name, hydrofluoric acid, and our symbols, our formula would be HF. That's it. +1, -1. And that is all.